A young tree is being supported by 4 ropes attached to a force ring around its trunk. So this is the figure. The ropes pull the ring in different directions to keep the tree stable during strong winds. The 4 ropes exert the following forces on the ring. We have here 25 Newton north, 35 Newton west, 40 Newton 30 degree north of east, and 30 Newton 45 degrees south of west. And so we have here the 3 questions. Determine the resultant force acting on the ring. Give both its magnitude and direction. And letter B, the tree needs to remain in equilibrium. What additional force must be applied to the ring to balance all 4 forces? Give the magnitude and direction of this force. Give the direction from the positive x-axis, which is north of east. And letter C, if you were the person installing the support rope, in what direction you should attach the 5th rope so that it provides the required balancing force referencing from east going to south. So the first thing that we need to do is to write the table wherein we could write now the values, then followed by the direction in normal or the proper direction referencing from positive x-axis. And of course, we're gonna have now our x component of the force as well as the y component. So we're gonna fill this table. First, we need to write the values. And so first we have 25 Newton north, followed by 35 Newton west, and then 40 Newton 30 degree north of east, and then 30 Newton 45 degree south of west. Let me just transfer this to the other page. So here's the first question. Determine the resultant force acting on the ring. So 25 Newton north, if we were gonna imagine that direction, we need to write the proper direction coming from the positive x-axis. And so we have here north. And so this one can be represented by 25 Newton north. And the direction for that is 90 degrees. So here it is 90 degrees. And then how about 35 Newton west? So this is the direction for the west. And here from 0, and then becomes 90, then up to here, this one is 180 degree. Just a bit of reminder that when you recall your Cartesian coordinate plane, this is 0 degree, this is 90 degree, this is 180 degree, and then this is 270 degree. Now, how about 4 Newton 30 degree north of east? So that means from east going to north around 30 degree. So this one is a 30 degree. And so the proper angle still 30 degree. And then we have 45 degrees south of west. That means from west going to south, that is 45 degree. And if you're gonna take note, that is from 180 degree, then plus 45, and then the proper angle here is 225 degree. And so we can now do our x component, wherein the value of our x component will be the magnitude multiplied to the cosine of the angle. And so from here, we're gonna have cosine of 90 degree multiplied to the value, which is 25 Newton. And since cosine 90 is 0, and then this one is 0 Newton. Next, we have this value, 35, multiplied to cosine of 180 degree. And cosine of 180 degree, if you press on your calculator, that is -1. and then this one will become negative 35 Newton. Next, we're gonna have 40 Newton multiplied to cosine of 30 degree, and the answer for that is, if you press that in your calculator, that is 34.64 Newton. And next one is 30 Newton multiplied to cosine of 225 degree, and that is negative 21.21 Newton. Now, how about for the y component? For the y component, you can simply adjust this first. For the y component, we will use the sine function. So for the first one, we're gonna have 25 multiplied to the sine of 90 degree. And sine of 90 is 1, that is 25 Newton. Next, we're gonna have 35 Newton multiplied to sine of 180 degrees. And the sine of 180 is 0, so this one is 0 Newton. Next, we have 40 multiplied to sine of 30. And sine of 30 degree, that is a special angle, that is 0.5, and that is 20 Newton. And next one will be 30 Newton multiplied to sine of 225. And so our answer here is negative 21.21 Newton. Now what we can do here is to get the sum of all the x component. So we have the summation of all the x component, and we have also the sum of all the y component. So if you're gonna press all of this, you have 0 plus negative 35 plus 34.64 plus negative 21.21. You're gonna get a value of negative 21.57 Newton. And for the summation of all the Fy, if you're gonna press your calculator, you're gonna have positive 23.79 Newton. Now, how about the resultant force? In order for us to get the resultant force, remember we have this formula that we had discussed, and we already discussed how we derive from this. We're gonna have the summation of all the fx and then square, it's like the Pythagorean theorem, and then the summation of all the Fy square. And then now the resultant force is simply plug in everything. We have 21.57 negative, then square, plus 23.79, then square. And if you're gonna press that in your calculator, we're gonna have a value of 32.11 Newton. And so this is our answer for the resultant force. Now, how about for the direction? For the direction, remember that we have here, for the angle, we're going to have the arctan of the summation of Fy over the summation of Fx. Be careful that the upper one is the summation of Fy, and so that this one will be the value. So let's write it down. So we're going to have here the arctan of positive 23.79 all over the value, which is negative 21.57 Newton. And so our angle, if you're gonna press that in your calculator, it will gonna give a 47.80 degree. So this is the reference angle. Okay, so this is the reference angle. Now, how about the actual direction? Okay, how about the actual direction? Now notice that the value of the y is positive and this one is negative 21. So perhaps you will see here it's negative 47.80. So if you will try to imagine our Cartesian plane, the y is positive, so this is the positive y, okay, and then the negative here, this is the negative x. And so here we say, okay, the angle we're gonna belong on quadrant 2. And so that means 47.80, so negative 47.80 from the reference angle. So this one is the 47.80 degree. And so what is now our proper angle? Our proper angle, if we want to have now the direction, that we could say as 47.80 degrees, we can say that is from north of west. That means from west going to the north, or if you want the north of east, the angle can be expressed as 180 degree minus 47.80, and that is 132.20 degree from positive x-axis. That means the angle is here from the positive going here, that is 132.20 degree. And you remember that this is the standard for math. Or we can say 132.20 degree north of east. Why? That is from east going to the north. And so what is now our final answer? The final answer is the resultant force, that is 32.11 Newton at 132.20 degree north of east, or you could say 47.80 degree north of west. So both of these directions are correct. And so perhaps if R3, we're gonna imagine this in the tree. So if this will be the tree, all the forces will be gonna concentrate on 47.8 degree north of west. So somehow this is here. So the tree will be pulled towards here. Okay? And so how about if this one, for the second question, look at the second question. So the tree needs to remain in equilibrium. What additional force must be applied to the ring to balance all four forces? Give the magnitude and direction of this force. So since the tree will gonna go here on this part, so can you imagine that the resultant force must be balanced and it must be pulled on this side. And so we're gonna add now this angle, which is, as you could observe, this is exactly 180 degree opposite to the resultant force. So this is the resultant force that we had computed, and so this is the force that we need to balance for letter B. And so if you will try to imagine the answer here, we have 132.20 north of east. So if this one will be our east, and then this is the 132.20 degree north of east. And so notice that from 130.20, I will gonna add another 180 degrees. And that is why for our letter B, our answer is 132.20 degree plus 180 degree, and that is the balancing force or the angle for the equilibrium force, that would be 312.20 degrees. So this one, so starting from here, going here, that is 312.20 degrees. And so what is now the magnitude and direction? So the same magnitude, that is 332.11 Newton at 312.20 degree, 312.20 degree. And if you want to be more specific with the direction, that is north of east. Now, how about for letter C? In what direction you should attach the fifth rope for us to have the south of east direction? And notice from the south to east direction, this is the angle. That means from east going to south. That is what we meant by south of east. And notice that is 360 degree, because the one who will circle, this one is the one who will circle. So 360 minus 312.20 degree, and that we're going to be equal to 47.80 degree. Now, what is the direction for that? That is south of east. That means from east going to the south. And that's it. That is for the answer for letter C. You just have to be very, very careful with your directions.